What's your grade?
Okay, everyone. Let me go over number one in detail here. Okay, so the first thing we want to do is make sure that we're spending time to factor out that B value. Otherwise, your C value is going to be thrown off. Okay. So we factor out a 1/4. So we have to make sure that we adjust. Okay, that we adjust our C value so that 1/4 times whatever we fill in here will end up giving us 3 pi over 8. So 1/4 times 3 pi over 2 gives us 3 pi over 8. So that's our B value, that's our C value. And then we can begin to build our period. So period is 2 pi over B. 2 pi divided by a fraction, make sure you're multiplying by the reciprocal. 8 pi is the cycle of our period. And then interval is 2 pi because we're doing 1/4 of the period. So first thing is we want to make sure that we start at 0 and we add our interval first. Once we have our interval in place, then we can begin to bring in that phase shift. So we subtract 3 pi over 2. Okay, from here, we know sine has a pattern starting at 0, increases down to -1, then to 0. There's amplitude is still 1, so it looks like it's not going to rise or fall any further than initially. But we do have a D value of 1, so we do have a midline at 1. So our 0 is really at 1, and then from there we can build our sine graph. Okay, any questions there?
Is this Monday? So which one was which? This one was Monday. Friday.
Okay, any questions with one? Oh, a couple of things I want to point out from the quizzes that you just took. So one big thing that I saw was students lost points just not factoring that B out, and so that ended up throwing off a lot of students' answers. Let me see, another big thing that I noticed from last Friday's quiz was, okay, tangent. You guys are pretty good about knowing that tangent starts in the middle of your table, right? That's 0. But what I saw a lot was many of you were also doing that to the same to cotangent as well. So cotangent doesn't start 0 in the center. Cotangent starts 0 on the left. So you do cotangent the same way, you build it the same way that you did sine, cosine, cosecant, right? You start on the left and then you build across. The only time that in your table you're filling that middle that third column with 0 is tangent. Okay, so don't do this for cotangent, only do this for tangent. Another common thing that I saw was the period formula. So make sure that you're choosing the correct period formula for cotangent and tangent. Both cotangent and tangent has a formula of pi over b, not 2 pi over b. So I saw that mistake quite a bit. Okay, 2 pi over b is for sine, cosecant, secant, and cosine. But for cotangent and tangent, the period is abbreviated. It's only going to be pi over b. So I think those are the 3 big things that seem to repeat itself amongst mistakes that I saw. Okay, so try number 3, and then we'll go over that. Okay, so 3 is a chance for you to practice using the new period formula for tangent and also knowing that for your interval, for your that you're starting at 0 for tangents.
Well, that technically is important.
The reason why things are formula, right? Formula 2 it's going to cost period really small. Period is small, sorry, B value is small. And all of a sudden, because of the way
Shifting to the left, that makes more sense.
Okay.
Thank you. I mean, I don't Yeah, see, it's supposed to intersect the and like that y.
It's like, oh, we gotta wear that too. Yeah, because like, even like,
That's like
that's the base. That's what I'm saying.
Like this one doesn't have a phase shift. Right. This one has a phase shift.
So like, that's which one are you on?
This one.
Why would we
Because
See, there's no phase shift for this one. Yes, you got no phase shift, so it's still at 0.
Yeah, but what about some of those?
It's the same exact thing.
Okay, that's an intersected 0. That's the whole thing. The bird watch.
That's 0. Why
My God. What is this number? Then how is it here? No, because look, this one 0 is 0, right?
Yeah.
This one 0 is a bird watch.
No, I'm.
I don't think you understand what I'm asking you. Or either that or I don't understand what you're saying.
We're just.
No, I
I don't know either, but I'm just going off of what it's
No, bro, you're so.
I'm just assuming that this is.
Pretty 0 doesn't have.
Like this.
You're starting off with 2 That's
Dimension.
Well,
Well, just you know it's going to be.
It's your fault.
So first thing.
Because I have to come here, right? Well, this one's 3,000.
If your B value is greater than 1, it's going to be a horizontal
No.
compression.
It's like.
In the interval.
If your B value is between 0 and 1,
Arrow, the arrow.
it's going to be a
You
horizontal.
can't solve it without the interval. Because if it wasn't in the
Okay, so
interval,
just
then
keep
you
that in
would say
mind.
it's without it was in the interval.
So if it's like 1/4, 1/5, 1/6, that's going to end up stretching.
Like they have the same.
So the B value, pi, so that would be
Oh,
7.
we get through 5, we're going to start with
So that would be pi over 7.
5 and 6.
Where did we get high?
That's just the period.
How do you get that?
So
Because this is where the interval.
yeah.
The period is pi, but in the interval it's 2 pi.
Yeah, that's it.
And then for an interval, would be
4.
1/4.
What?
4. We figured it out. Because it's pi over like, it's pi over 750. It is an interval of
Yeah,
2 pi. Because this is the value that I'm just making them up as I go. So you do 2 pi over 1500 and then that, no.
Okay, here's number 3.
So it's 4 because in order to get to 2 pi, you have to multiply pi over 754. And that's 0.
Okay, so let's check our work for number 3.
Yeah.
Okay. Remember that your period formula is pi over b. Once you factor that 1/2 out, we have a value of 5, b is 1/2, c is pi, and d is 3. Our period is going to be 2 pi, interval is pi over 2, so remember, this is tangent, so you want to start your 0 in the middle of your table. Subtract pi over 2 twice. Add pi over 2. And then once you have your original... Okay, once you have your original theta values, then we can work in our phase shift. So we can subtract pi from each of our terms. So we're going to go from negative 2 pi all the way to 0.
I did it right other than the entire problem. No, I mean, I got everything right for the period, so if the period is wrong, it's fine.
Okay, any questions with number 3?
Are we doing 4?
No, we're going to skip it down to 5. Yeah. Okay. So let's go to 5 because this is one that we want to make sure we know how to build, or we need to write our equation. Okay. Okay, so looking at number 5, what does this resemble? Does this resemble more a sine graph or cosine graph?
Cosine.
Cosine. So let's start with cosine because it's easier to deal with cosine because there's no shifts that needs to happen. Okay, so we'll start with cosine here. Now, if we look at cosine, we can figure out our a value and our d value. So we know this is the center of the graph is at 1. That's our d value. And then if we just simply measure the distance from the center to the top, that's our amplitude. So what's our a value? 2. Okay. So now the next thing is, what is the length of this period for cosine? So what do you guys think? Yeah, so if we look, cosine is peak to peak, right? So we start at 3 and okay. So if we go to pi, then that's too much, right? It would have completed 2 cycles by pi. So your period is only pi over 2. Okay, so from this period information, we can find our b value. Divide both sides by pi, we get b is equal to 4. Now, this may not be as important right now because there's no shift going on, but I think it's helpful if we go ahead and find our interval. Okay, so our interval is 1/4 times the period. Our period is pi over 2. So our interval is pi over 8. Okay, so we'll hold on to that information. We're not going to need it right now, but we may need it a little bit later. Okay, so let's write our cosine equation. We have our a value, our d value, we have our b value. We know there's no shift, so that makes it a little bit easier to create. Sorry, we didn't need this bracket here. Okay, so y equals 2 cosine of 4 theta plus 1. There's no C value, there's no shift, because the graph is already centered right where we would expect cosine to be. Okay, so any questions with cosine? Okay, now with sine, what we can do is we can create a graph that lives nearby that has similar pattern as our graph. So normally we like to think of sine as starting at 0. So I'm going to draw a sine graph. It's going to share a lot of information from what we've already gathered. Share the same information. A value, D value is just, it's going to be a little bit, the shift is going to be different. So let's write out our sine equation that I have in green here. So A is going to stay the same. B stays the same. And the D stays the same. Okay. So what can I do with my, this is what I'm looking at right now, this graph in green. What can I do with this sine graph to turn it into the graph that is shown originally? Which direction am I going to shift? Left. And it's just going to be one tick mark, right? And we found that the interval is pi over 8. So we're just going to shift it left, pi over 8. Okay. Okay, does that make sense?
We're doing number 6.
Yes, I would like for you guys to try number 6 because we did number 5 together, and I'm hoping that if we can do number 6 or try number 6, we can see whether we're comfortable with because I think this is the problem that a lot of us maybe had some questions about on the quiz. So I wanted you guys to try number 6 first. Now, just a little bit of a hint. Now, if you look at number 6, what do you think in this one is the easier one to start with? Sine. Yeah, I think this graph resembles more the sine graph. So I would start with sine, do the easier one first, and then we can work in the cosine later. Oh, sorry, that should be sine. Thanks. Okay, sorry about that. Okay, number 6, you're going to start with sine. Draw your midline. That's where your D value is. From the midline, you can measure to the top, the peak of the graph to figure out your A value. See if you can identify what the period of this graph is, and then from there you can find your B value.
Oh, because we just looked at the graph.
Yeah. Sorry. Even if I looked at it, even if I looked at it.
Hold on, this is great.
Or mine.
Guys, on my key, I think I accidentally left off -2.
Yeah.
Sorry about that.
I mean, we could do both. It literally doesn't matter.
Wait, so you're saying if you do plus or minus pi?
No. This here, -2.
No, but yeah, pi.
The patient. Would it technically also- Because I put -1.
Okay, if you did plus pi here, that means you would have to, yeah, get you up to -4. So I think the easier one is do minus pi, but if you do plus, you can flip it. That works too.
Oh, okay.
I'm just stuck on number 10.
I don't think you can wait.
Okay, any questions with number 6?
Are we doing 7?
Yes, I do want to go over 7 with you. Okay, no questions with 6?
I'm gonna draw on your paper.
Okay, let's go to number 7. Okay, so number 7. Let me review tangent and cotangent here. So tangent has a positive slope, and on the left side it goes from -π/4 to π/4. The period is just 1 pi. Same thing with cotangent. Period is just 1 pi, but has a negative slope. Starts at 0 and it goes to pi. It's a little bit more straightforward because it's not split on either side of the y-axis. Okay, so let's look at number 7 here. Okay, which one do they both? Neither tangent or cotangent can be accomplished without shifting. Okay, so I don't know. I think there's an easier one, but it's not. But both of them requires shifting. It doesn't land nicely with either tangent or cotangent. Okay, so which one would you want to start with? I don't know if there's an easier one or not. Cotangent. Okay, so maybe you're looking at that slope here, and it looks like it's a better fit for cotangent. Okay, so we want to match it up with cotangent. Now, cotangent normally goes from 0 to pi, but this one looks like it's starting at, where do you think that asymptote is occurring here? So, so this is half a pi, so I think this is going to be a 4, right? A 4, okay. Now, it's still able to complete its cycle within 1 pi, because this over here, yeah, this one, okay, you guys were saying this is -3 π/4. Okay. Okay, so it is still the same b value. So a lot of things are going to stay the same. A is still 1 because we're still going from -1, 0, 1. D is still 0, and our B is still 1. So really it's the C value that is the only thing that needs to be adjusted. So if we think about our cotangent normally we would go from 0 to pi. So we can create our cotangent graph, and then we can just make it shift to the right. Okay. So right now, the cotangent graph would be here. And if I want to make this match this graph, I'm just going to move it to the right, π/4. So minus π/4. Okay. Now let's go to our tangent graph. So normally tangent graph would go from -π/4 to π/4. But this one is going from negative 3 pi over 4. I'm sorry. Normally, my bad, not negative pi over 4, negative pi over 2. Normally go from negative pi over 2 to pi over 2. So if I superimpose it onto this graph, this is what our tangent graph would look like initially. So what can I do with the tangent graph to make it look like this graph here? Okay, yep, so I want to reflect it, and I'm going to shift it to the left. Okay. So I can simply start with this graph, flip it, reflect it, and then shift it left 1 unit, and then that way it'll be negative 3 pi over 4 to pi over 4. Yes. Cotangent plus pi over 4. That means you want to shift it to the left. So if I'm starting with cotangent, if I shift to the left, then it'll go from negative pi over 4 to 3 pi over 4. So I don't think that's going to line up with this graph, right? So if I take this graph and shift it left, it's not going to line up with this graph. So I need to take this graph, I need to shift it to the right to make it look like this graph.
Oh, I see.
Yes, I'm starting here and I'm moving it to make it match this. Yes. Question?
So I was just wondering, so is that how it always works? Is it always like to go from tangent to tangent, you always reflect and shift it? So it's like a formula kind of?
Yeah, basically. I mean, because you know that they are off by they're off by pi over 2, and then one is positive slope and the other is negative slope. So if you can kind of just use those two things to kind of help you convince yourself.
You're covering.
Okay. Yes, question? Okay, let me see. Negative pi over.
I don't understand.
Yeah, I think you've got a good point here. This is lining up to be where our y value is, and it's not quite at 1, even though we do see that 1 there, it's not lining up. So you're right, this is probably more like 1/3 or definitely less 1/2. But I won't give you 1, or if you put it as amplitude of 1, I won't take off any points because this is just hard to see. Okay. Yes. Oh, I was just creating what the original tangent graph was, and I wanted to have that picture and then just imagine what I would need to do to it to make it turn into the original graph.
This is so much. No, this like actually makes so much sense. No. This makes so much sense.
Okay, number 8. Every sign, let's see, true or false, explain why. Every sign function of the form a sine of bx minus c plus d can also be written as cosine function. Okay, it's true or false? Well, remember, every sine function we can just write as a cosine function by just simply shifting it, right? So since they're only off by pi over 2, we're able to just change that c value to make it match, right? We saw it with the quiz and the previous problem that we did. Any sine graph, we can just shift it to make it a cosine graph or vice versa, right? Yes.
But if you shift to the sine graph, or if you shift to a cosine graph, I think
Well, it'll just be 0. That's also a c value, right? I can just replace this. And then, but we can also change the a value if we want to reflect it. So the a can also be a part of that as well. Yes, question?
So you can have it in the same form, but you just change what exact numbers there are? Like,
Yes.
If there was no shift.
If there was no shift, the c would just be 0. So
Oh,
that's still considered a c value.
Okay.
Okay, number 9. True or false? The period of cosine of 8 theta is equal to 4 times the period of g of x equals cosine of 2 theta. I think here we just go ahead and find the period for both and just compare them and see which one is larger and see what the relationship is between them. So they both can be used as using period equals 2 pi over b. So one has a b value of 8, the other has a b value of 2, and we end up with pi over 4 versus pi. So it's kind of flipped around, right? This is the larger one. So the cosine 2 theta is actually 4 times, right? So it's a false statement, and we can correct that statement here. Okay, number 10. If x equals theta is an asymptote of y equals cosecant of x, then x equals theta is also an asymptote of cotangent of x. Okay, how can we rewrite cosecant of x? Cosecant of x is just what? 1 over sine. What's cotangent in terms of sine or cosine? So tangent is sine over cosine because it's y over x. Yep, so cotangent is cosine over sine. So if we compare those two in terms of, you see that cosecant is 1 over sine, cotangent is cosine over sine. They both have the same denominator. So whatever causes sine to be 0, both cosecant and cotangent will experience undefined, right? So they both will share the same asymptotes because they have the same denominator. Okay, you don't need this table here, just the reasoning here. Yes. Right. So cosecant is 1 over sine, and then cotangent, we know how before we would always, on the unit circle, I would say cotangent is x over y. X over y is really cosine over sine. So we know that vertical asymptotes comes from the denominator. So whatever causes sine to be 0 will be a vertical asymptote for cosecant. But whatever causes sine to be 0 is also going to cause cotangent to be undefined. So if you see that the denominator is the same variable, then whatever causes one to be undefined will also cause the other to be undefined. Okay, so I said that whenever sine of x equals 0, both cosecant and cotangent are undefined, and so therefore they share the same asymptotes. Therefore, they share the same asymptotes. Okay, number 11 seems complex, but we're just going to start with something that we do know. Okay, let's start with an easy version of this problem. Let's just do cosine of theta. Okay, how many zeros does cosine of theta have between 0 and 2 pi? Okay, let's look. Starts at 1, goes to 0, -1, 0, and 1. Okay. So we have 2 zeros. Okay, what if we just increase the value of the coefficient, but then let's do a number that's more manageable. Let's do cosine of 2 theta. Okay, what does this graph look like? What's the period going to be for cosine of 2 theta? Pi. So that means it's going to complete its cycle in half the time, right? So imagine I have the same graph. It's going to complete the cycle in the same, so it's going to have to do this, right? So by the time it reaches 2 pi, it would have completed 2 full cycles. How many zeros do we have here? 4. So is there a pattern that you can see here? Okay, we just take this b value and multiply by 2. So can we adapt that for this problem? Obviously, this is going to be a very, very short period, but just like how we did before, we can just take this, multiply, because we know that each cycle is going to experience 2 zeros. So we should be expecting 3,000 zeros in that interval from 0 to 2 pi. It'll work for sine and cosine, yes. Study for your test. Oh, one more thing I want to go over is domain and range for parent graphs. Okay. And I will send this out through Remind as well, or you can take a picture of it. So sine and cosine has domain and range, -infinity to infinity, but the range is from -1 to 1, right? Cosecant, wherever sine is 0, which is pi, we know those will be vertical asymptotes. And then the range, we know there's a break, right? Infinity to 1 to -1, and then from 1 to infinity, because we have all those upside down parabolas. Okay, for secants, it's going to be pi over 2 plus pi n, because those are all places where cosine is 0. So wherever cosine is 0, it's going to be the asymptotes, and then we just identify that first location and add pi n. And then tangent is sine over cosine, so it's going to share the same asymptotes as secant. But the range is negative plus infinity because the graph just extends in both directions. And then cotangent has the same denominator as sine, or as cosecant. So they both will be x equals pi n. But I'll take a picture of this and then I'll send it to you, and I'll also put it on my website under today's date. Okay, so I have a help session tomorrow morning at 7:30, and also during fourth period. So if you want to come in either time, we can do some more additional practice problems.
It would still be just to the right.
No.
So
Thursday. I'm going to.
so you're asking about which one? Okay, you're asking about tangent or cosine? One second.
Students who ride bus 4531